So looking at number 6, we're going to be solving the inequality, and we're going to graph the solution set on a number line and write it in interval notation. So when you have an absolute value and you have an inequality, there's one of two scenarios that is going to happen for, is it going to be how we're going to solve it. There are two special cases as well, but typically on a test situation, we're going to give you something you can actually solve. So for this one, this is an absolute value which is less than a positive number. When you have an absolute value which is isolated and a less than and a number that is positive, the way we solve it is we put the inside part in between -6 to +6. So it's the in-between case when it's less than. So then when we try to solve this, we would need to multiply everything by 3. So that would make this -18 less than 2 plus 4x less than +18. So I multiplied everything all the way across by 3. I would subtract 2 from all three sides. And so this would be -20 less than 4x less than 16. And then we divide everything by 4. So this one's going to come out to -5 less than x less than 4. So -5 less than x less than 4. In interval notation, that would be, when you write interval notation, you're always trying to tell me, if I was shading this on the number line, what would be the start and the end of my shading. That's what your interval notation tells you. So if we were going to shade this, this would have been -5 with a parentheses up to 4 with a parentheses, and x is in the middle. So imagine shading that throughout the middle. In interval notation, that's -5 with a parentheses, comma 4 parentheses. So that's where I started shading and where I ended shading. Any questions about that one, or is that okay? Yes, Ty. You can split it into two scenarios. I don't always recommend it because then you have to, when you shade that, you have to remember that and means intersection. Ty was asking if you could split this into two separate pieces and solve them individually. You can do that. That's absolutely a true statement, but you're going to get two different shadings that are heading in opposite directions, and means intersection, so you have to remember that it means the part in the middle. So it just creates more work for you, is the only problem. Does that answer your question? Okay, anybody else have any questions on 6 before we move on to the next one? And Madison, did that help a little bit with the interval notation? We're probably going to see some more of it, but did that help a little bit? Okay, so if you guys are good with 1 through 7, we're going to scroll down and look at what the next subgroup of questions is. Now, from what I'd already seen from people, I had 10, 11, 12, and 15 marked. Does anybody have anything else that's not highlighted that they would like me to work out? Okay, so we're going to add 9. And 13 and 14. Okay. Are we doing all parts of 14, Journey? Okay. All right, so this group is, and this is kind of the middle of the exam, so this is where a lot of times people have a lot of questions, so I expected this. So if it's okay with everybody, I'm going to start with number 9, and we're just going to work through them one at a time, and I'll ask for clarification or questions after each one to see if you have any issues. And because these are lengthier, I'm going to open up a Word document and just do all of my work one problem at a time over there. So let me see what we've got for the first one. So it's going to flip back and forth a couple times because not as sophisticated as I would like to be with extra windows. So for Number 9, it's x minus 3 over x squared minus 16, and then greater than 0. Okay, so x minus 3 over x squared minus 16 greater than 0. So this is for number 9. We're supposed to solve the inequality, and we're supposed to write our answer in interval notation. Because this one has x's in the denominator, it's going to be something we need a sign chart for. The first step is always to get 0 on the right side, so we're in a good place here. And then yes, Ty. Did I miscopy it? Hang on just a second. Flipping back and forth doesn't help. No, number 9 has a 0 on the right side. Number 10 has a 1 on the right side. Did you need number 9? Okay, so Ty's question was number 9. He says he's good now. Does anybody need me to work through number 9 completely? Or do you want to go to number 10 where there's a 1 on the right side? Okay, I'm going to go ahead and do it. It's not going to hurt anybody. So let me go back to my Word document. Okay, so if you factor this denominator, that would be x plus 4 and x minus 4 because of the perfect squares. We've got a 0 on the right side, so we're good there. And then we would make our chart because our top value that equals 0 is positive 3. Our two bottom values would be negative 4 and positive 4. And then we are going to place them, remember, on a number line from least to greatest. So negative 4 would be first, then 3, then 4. Top number follows the actual symbol. So since there's no equal to, that's going to be open. Bottom is always open. So we're going to be just leaving those as open circles as well. So all 3 of those critical values are open circles. So this would be negative infinity to negative 4, negative 4 to 3, because we're just going through the number line, 3 to 4, and 4 to infinity. We pick a test value in each region. So I'm going to pick something smaller than negative 4, so negative 5. Something between negative 4 and 3, I like 0. I'm going to have to pick a decimal for that one since there's no nice numbers in between. And something bigger than 4, I'm going to pick 5. You take your 3 factors, x minus 3, x plus 4, and x minus 4. You place them on this column right here. And then you want your final answer to be greater than 0, which is a positive answer overall. So we just plug this number individually into each of these factors. Negative 5 minus 3 would be negative. Negative 5 plus 4 is also negative. Negative 5 minus 4 is negative. 3 negatives multiplied together makes a negative. 0 minus 3 is negative. 0 plus 4 is positive. 0 minus 4 is negative. 2 negatives multiplied together make a positive. The pluses don't really even matter. They're not going to change any signs. 3.5 minus 3 is positive. 3.5 plus 4 is positive. 3.5 minus 4, though, is negative. 1 negative multiplied by all those other things is going to make the whole thing negative. And then 5 plugs into each of those and makes all 3 of them positive. 3 positives multiplied together is a positive. We were looking for greater than 0, so that means the regions that work are the 2 positives. And remember, your final answer is interval notation. So negative 4 to 3 unioned with, because we have a gap, 4 to infinity. Any questions on number 9, or do we feel okay about that one? Okay, looks like we're mostly good. If you have a question, please speak up or type something in. So we're going to try number 10 next. The variation of number 10 is that all of a sudden now we're going to have the number on the right side. So we now have to worry about moving that over. And that does make the problem more involved algebraically. So let me look at what that one was. It is 2x plus 5 over x minus 4 greater than or equal to 1. So 2x plus 5 over x minus 4 greater than or equal to 1. Let me double check myself because it will not work out right if you don't copy it right. So it looks like we're good. Okay, the first step on this one is that you have to move the 1 over. You cannot have that when you're trying to solve these sign charts. You have to be 0 on this side. So if we move it over, imagine subtracting it. I'm going to write it as 1 over 1. And then I would want to get a common denominator. Well, the common denominator will be the x minus 4. So this would be 2x plus 5. We need to distribute this negative with that 1. So that's going to be, and I have no idea why I have a parentheses there. So 2x plus 5 minus x plus 4 all over x minus 4 greater than or equal to 0. Combine like terms on top and you get x plus 9 over x minus 4. Okay, so my top value would be negative 9. That's what makes that 0. My bottom value would be a positive 4. And the bottom is always open. Top obeys the symbol. So top has an equal to, so we're going to go with closed. Remember, that just tells you if it's a bracket or a parentheses. So then we need to place these numbers just like last time on the chart. So we have negative 9 is smaller and 4 is larger. So this would be a closed circle here, an open circle here. And then this is negative infinity to negative 9 bracket, bracket negative 9 to the positive 4, parentheses, parentheses 4 to infinity. Something smaller than negative 9, I'm going to go with negative 10. Between negative 9 and 4 is 0. Bigger than 4, I'm going to do 6. I need my factors, x plus 9 and x minus 4. And we want this to be greater than or equal to 0. So if we plug it in, negative 10 minus or plus 9 would be negative 1. Negative 10 minus 4 is negative 14. Negative times negative is positive. 0 plus 9 is positive 9. 0 minus 4 is negative 4. Overall negative when you multiply together. This would be 15, so that's positive, and 2, and then that's positive times positive, which is positive. Since we were looking for greater than or equal to 0, we're going to go with the two positive cases. So this is negative infinity to negative 9 bracket, union with 4 to infinity. Any questions on that one? And I think I have some kind of chat. So let me pull that open. Are you guys okay? All right, let me pull back open the review and see what our next question was. So it looks like we had a question about 11. I'm going to probably work this one out on the Word document as well, just because we didn't leave a lot of spacing here. So it says we're going to find the equation of the line through 8, negative 5, and 4, 0. And we're going to write our answer in slope-intercept. Remember that slope-intercept is y equals mx plus b. So our final format should look like that, where that's the slope and the y-intercept. To be able to do this, you have to find the slope. Anytime you want to write an equation of a line, you need two things. You need the slope and you need a point on your line. We already have a point on our line because we actually have two of them. So we need the slope. So let me copy these points over and we will work them out. So for number 11, we had, I have way too much trig stuff open. 8, -5, and 4, 0. Okay, so when you want to find the slope of a line, you have a formula for that. It's the change in y, which we say is y2 minus y1, over the change in x, which is x2 minus x1. x1 and y1 and x2 and y2 refer to what ordered pair it came from. The first ordered pair is the first x and first y. The second ordered pair is the second x and the second y. If you change the order of these, it doesn't matter as long as these two things are both a 1 or these two things are both a 1. You have to be consistent there. So in our formula, you can just think of this as filling in some blanks. There's subtraction in the formula, but we're going to fill in these numbers. So y2 is 0, y1 is -5, x2 is 4, x1 is 8. 0 minus -5 is actually +5, so that's just 5. 4 minus 8 is -4. Now typically you want to make sure this is a reduced fraction, but there's nothing we can reduce here, so this is a slope of -5/4. When you want to write an equation, you have a second formula besides slope-intercept. We call it the point-slope formula. Point-slope is how you find any equation from a point and a slope. So you write y minus y1 equals m parentheses x minus x1. So this is the formula for point-slope. Now, all that happens in this formula is that you plug in one of your points, x and its y, and you plug in your slope. It doesn't matter which point you pick, so I'm going to pick the one that looks easier to plug in. So y minus 0 equals -5/4 x minus 4. You do have to make sure you pick both of these values from the same ordered pair. This would be distributing -5/4, so this will be y minus 0 is just y. This would be -5/4 x. This would be -5 times -4, because think of that being over 1. So that's +20 divided by 4. So that's going to be +5. So there is my slope-intercept form for that equation. Any questions on number 11? Okay. Yeah, if you had enough, so like say I had plugged in the other point, the 8 and the -5, you would have had y minus a -5. So you would have had like a +5 there. You would have subtracted it over. You should still get the same equation because the points are both on the same line. What'll happen is usually you'll have some fractions or something to reduce. Okay, so Journey, what do you mean by the final answer, like from the point slope part? Okay, so this is a formula that we use anytime we have a point and a slope. It is our kind of our gateway to getting a point and a slope to turn into an equation. So what you do is, this is the slope formula. A lot of people don't realize that this formula right here that most people know is exactly this formula. What they did is, instead of calling this 2 and 2 for the y2 and the x2, they've just called it an arbitrary y and an arbitrary x, which means it's a variable. So essentially the difference between this formula and this is they've multiplied the x's over to be with the m. So when you're doing this, all you're doing is plugging in one of the ordered pairs for the x and the y here and the slope. So I plugged in 0 for y2, which didn't matter if it was y2 or y1. You can pick either point. I plugged in my -5/4 and I plugged in my 4. When I want to solve this, I wanted to get it into y equals mx plus b. That was what the directions told me, slope-intercept. So I needed to distribute, and then I needed to add over that 0, which was just 0. The distributing part is usually what gets people, because when you do the first one, it's just times x. But when you do the second one, you're doing -5/4 times -4/1. So this is really 20/4, which is +5. So that's where that number came from. Yes, you do need to know your point slope formula. Slope-intercept, you don't really have to memorize it. You just have to remember that you have to solve for y. So once that's all slope-intercept is. If you know point slope and you know the slope formula, that's pretty much what gets you to everything else. Did that answer everybody's questions on that one? Okay, so then let's go back and look at, I think the next one was number 12. And if you're just joining us, I've seen some people coming in and out. I don't know if you're coming in brand new or if you are just signing off and back on because some have kind of glitched. We are just working through specific examples people have asked for on the review problems. So let's look at number 12. Number 12 is a little different. It says find the equation of a line through a point. So notice we already have a point, but they want it to be perpendicular to a specific line. So what you have to know here, and this was in that video series that I asked you guys to watch because I said it was part of our material, that it's Math 100, but it's still, part of 136. We want to write our answer in slope-intercept. So you have to know what perpendicular means. Two lines are perpendicular if they cross each other at 90 degrees. So the only time that happens is if this slope is, say, a positive a/b. The only way this can cross at 90 degrees is if this slope is the reciprocal and the opposite sign, because one of them is going uphill and the other one's going downhill. So to be perpendicular, whatever your slope is here, the other slope has to be flipped and the sign has to be changed. So that means that this slope right here needs to be flipped to -2/3 for us to be able to use it for our new line. So that's what that means. So for us, we're going to have to take this and we're going to have to take this point. So our new slope, our perpendicular slope, and our new point, and we're going to do point slope again. So since I've got room, I'm just going to write this one out here. So here's the work for this one. So we're going to do y minus -5, because that's, remember, our point slope formula. You do y minus the y value equals the slope, so that's -2/3, and then x minus the x value, so minus -2. It's always minus in the middle and then whatever the sign of the number is. So this is going to change to y plus 5. This is going to be -2/3 x plus 2. Here's a quick trick. A lot of times students don't want to distribute a fraction because it'll make messier fractions. You can just get rid of that by multiplying both sides by the denominator. So if you multiply this by 3 and do the same thing to the other side, that will clear out that little denominator there. So this would be 3y plus 15, because we need to distribute the 3. And then on this side, we're going to distribute the -2. So that would be -2x and -4. To get this in slope-intercept, because that's what they asked for, you need to solve for y. That's what that means. So we need to subtract 15, which would make that -19, and then divide everything by 3. So it looks like the answer to number 12 should be y equals -2/3 x minus 19/3. So perpendicular means flip the sign and the fraction of that slope. You change both parts. Any questions on 12? Yeah, so anytime you're doing a perpendicular equation to something that they've given you, you want to flip and change the slope always. That's for perpendicular. But you have to change the sign too. It's not just the reciprocal. So if this had been a -3/2, we would have used +2/3 as our perpendicular slope. and then you just go through the same motions as before. You use your point slope formula. Are we okay with 12? Do we feel like we're ready to move on to 13? Okay, so for 13, you're supposed to be finding the equation of a line with a point 5, negative 1, and it's parallel to 3x minus 4y equals 18. Notice this is different. When the perpendicular one was here, it was already solved for y for me, so I could see that slope of 3/2 really clearly. This is not in slope-intercept form, so I'm going to have to adjust that first before I know what my slope is. But parallel means that you don't change the slope, you keep the slope the same. So once we figure out what our slope is, we're going to keep it that slope, and then we'll use our new point. So I'm going to copy this one onto a new screen, at least the main information. So we have 5, negative 1 as the point. And this is for number 13, I think. And the equation was 3x minus 4y equals 18. So we want to be parallel to 3x minus 4y equals 18. I have the memory of a goldfish. Yep, that's right. Okay. So let's work this one out. So the first step here is we need to get this into slope-intercept, or we don't know what the slope is. If you're not in y equals mx plus b, you have no idea what your slope is. So to do this, we need to solve that by subtracting that 3x over. So this is negative 4y equals negative 3x and a positive 18. You cannot add those together because they are not like terms. And then you divide everything by the negative 4. Now, the only part about this, we don't even care about this 18 over 4. We care about the slope right there. That comes out as a positive 3/4 x, and if you want, you can go ahead and reduce that to 9/2. But the part we care about is right here. So this is the slope of the original line. To be parallel, we want to keep the same slope. So for our new equation, we're still going to use 3/4. If that had said perpendicular, we would have made it negative 4 over 3. But that's the key thing, is knowing the difference between the two words. Parallel lines stay the same distance away. They never touch. So you have to keep the same slope. Perpendicular lines, remember, intersect. So for this, we're going to be doing the y minus y1 again equals m parentheses x minus x1. So this is y minus negative 1 equals 3/4 x minus 5. That's y plus 1 equals 3/4 x minus 5. You can distribute this, or you can get rid of the 4. I like to get rid of it. So if I multiply it on one side, I have to do it to the other. So that cancels out that denominator. This would be 4y plus 4 equals 3x minus 15. And I believe our directions were we slope-intercept again? Let me double check. Yes, slope-intercept still. So we're going to put this in the y equals mx plus b. So minus 4, which makes that minus 19, and then divide everything by 4. So my final equation would be 3/4 x minus 19 over 4. Y equals all of that. Any questions on 13 before we move on? Okay. So I believe the last one of the lines comes in number 14, and then we move on to functions. So for 14, there is a little bit going on here that's different. First of all, it's kind of reminding you that we taught you the distance and the midpoint formula. And then there's this one extra question. I would put a star by C. It is absolutely on the exam. Okay, so this is one that I would make sure you know how to do. The This is not really any different than anything we just did, except they've added an extra word here called the perpendicular bisector. This means you have the opposite reciprocal slope. That's what perpendicular means. And this means you use a very specific point for your line. That point is the midpoint. So usually how this works in this question is we ask you to find the midpoint before we ask you to do the equation. So you already have the midpoint, you just need to know how to do the perpendicular bisector part. And it's really the same steps as before. The other thing that's different is they asked for us to write our answer in general form. General form means that you have your x and your y on the same side together. So ax plus by equals c. Also, one thing about general form that is really picky, they do not allow fractions. So I'll show you how to deal with that if you have a fraction. So let's go through this one. So we have 2 points, and we're going to find the distance formulas because they said find the exact distance. We're going to find the midpoint of the 2 points, and then we're going to find the perpendicular bisector. So let me go back because it's going to take a little bit of work for this one. And there we go. Need writing room. So for 14, our 2 points are, because I've already forgot what they are, -2, -1, and -6, 5. And they ask us to do 3 things. The first thing is the distance, and it does say exact distance, which means you do not go to a decimal approximation. So the distance formula, remember we learned this one on the day, we learned it in the videos, but I put it on the board for the day of the quiz. You do not get that on the test. You do have to know it. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so you subtract the x's, you square it. You add that 2, subtract the y's, you square it. And then we take a big square root. So this is, and remember if you want to label them, x1, y1, x2, y2. So this would be -6 minus -2 squared plus 5 minus -1 squared. The minus negatives will change to plus plus. So this is actually -4 squared plus 6 squared. You need to square them, and negatives will, when you square them, turn positive. So that's going to be 16 plus 36. We then add them together. So that's going to be 52. And then your question you have to ask before you stop is, are there any perfect squares that go into 52? And it's actually 4 times 13. So this would be square root of 4 is 2 on the square root of 13. So that would be the final answer for part A. Any questions on just part A? Okay, so for part B, we're supposed to find the midpoint. The midpoint is just to find the average between the 2 points. So to find your midpoint, I'm just going to try to squeeze it in right here because it's not much work. You take the x's, you add them together, you cut it in half. You take the y's, you add them together, you cut it in half. Notice this is a subtraction, whereas this is addition. It doesn't mean you're always going to add, it just means you don't change any signs right here. So x1 is -2 plus -6 for x2. We're going to cut that in half. And then -1 plus 5, and we're going to cut that in half. That's -8 over 2 and 4 over 2 for a final midpoint of -4, 2. So there's my midpoint. Now what they want you to do for part C is to find a perpendicular bisector. And like I said, that is the same thing we were doing before, except we have one extra feature we have to worry about. So perpendicular bisector has the following steps. For this, you need to know your old slope and then make it perpendicular. So we'll have to go back and find the slope of those two original points. And then for the bisector, we just make sure we use our midpoint and our formula. So the original 2 points, if we look back up here, so we do have to do something with them. We have to find their old slope because we want something perpendicular to these two. So we were going to be doing, I'm going to go ahead and write it again down here. So -2, -1, and -6, 5. So I'm going to find the slope of this. So that'd be 5 minus -1, because that's my y's, over -6 minus -2. Plus, 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 because two double negatives. So that's 6 over -4, or my old slope, this is the original slope, is -3/2. So the perpendicular slope to that, because that's the one we want, would be +2/3. So there's one part of what I need. The midpoint we just found was -4/2, I believe. Let me scroll back up. Yeah, so -4/2. There's the other part that I need. You take your perpendicular slope and your midpoint, and that's now a perpendicular bisector piece of information. We put that into our point slope formula. So remember, that's this formula. So that's y minus 2 equals 2/3 x minus -4. So that's going to be plus plus. If you want, you can clear out your fraction here. So this would be 3y minus 6. You still have to distribute this 2, so that's going to be 2x plus 8. And then here's where things are a little different. Because they asked us for general form, you have to get the x's and y's on the same side and the constant on the other side. That's the only difference between slope-intercept and general form. We've already gotten rid of all the fractions when we cleared this. So I'm going to subtract the 2x over to the left. I bring down my plus 3y, and I'm going to add the 6 over, so that equals 14. Now, I'm okay with this answer on the test, but there are books that say that the beginning cannot be negative, so the alternative is sometimes you have to change all the signs by multiplying by -1. If you remember to do that on the test, great. If you have this and it's all correct, I'm still going to give you full credit. But specifically, most textbooks say no fractions in general form and the leading coefficient has to be positive. And you do have to write the x term first. There's no option there. So the only way to fix that would be to change all of the signs by multiplying by -1. But again, I'm not that nitpicky on the exam. So any questions on that one? Yeah, that one's a long one. I do apologize. But it tests the distance formula and the midpoint formula, and it also tests if you understand the word perpendicular. So it's a good question because it tests all of those things. Okay, so let me go back to our problem set because that was all of the line stuff. So now we're at 15. Do I need to do both of these, or do you guys have a specific one? They're exactly the same. There's just two different versions. Is there a specific one anyone wanted to see for 15? If you guys say no, I'm just going to pick one or both. Okay, we can do both. So for these, you're talking about the domain, and you're going to write it in interval notation. So domain means, remember, what x's can you plug in? If you have an even root, you have to make sure that that part stays greater than or equal to 0. So that's your first step. So if we solve that over, that means that all of my x's that I'm looking at have to be greater than or equal to 2. The other problem we have here is that there are x's in our denominator. So if we were to factor that bottom, factors of 30 that makes -7, and it's a -30 when we multiply. I believe that'd be -10 and +3 when we factor it. So that means we don't want x to ever equal a +10 or a -3, because notice that would make one of those, each of those would make one of those equal 0. So we have two things going on. We have to have our x has to be greater than or equal to 2, and it can't be 10 or -3. The only one of these that actually causes problems over here is 10, because you've already thrown out -3. Being greater than or equal to 2 means -3 was never an option to begin with. So remember, I think in class I kind of showed you it this way. I said, imagine being a 2. Here's -3, here's 10. Greater than or equal to 2 means you're shading this direction. So -3 is way over here. It's not even in the shaded part. But the 10 is, so we need to skip that number. So we're going to leave an open circle there. So that means in interval notation, this would be 2 to 10 unioned with 10 to infinity. So that would be my domain. Same thing for B. We would say this is x plus 6 needs to be greater than or equal to 0. So that's greater than or equal to -6. We would factor these denominators. Factors of 16 that add to -10 would be -8 and -2, and it multiplies to +16. So x cannot equal 2 or 8. Now, -6 is over here. 2 and 8 are both to the right. If you're saying you're greater than or equal to -6, you're going to have to skip over both of those numbers, because your shading is going to cross both of their paths. So on this one, you're going to get 3 intervals. This would be -6 to 2, union 2 to 8, union 8 to infinity. So that would be the domain of that one. Does that clarify or help for number 15? Are we good? Okay, I'm going to help you guys out. Just because we're running short on time and it's getting late. I'm going to do 16. 16 and 17 are the same thing. I'm letting you know that this one's more likely to be on the test. Is that cool with everybody? Because we don't want to stress ourselves out over ones that are a little bit harder and they're not going to be on the exam. So let's look at 16. And this is that difference quotient. So this is that f of x plus h minus f of x all over h. So we need to do that function evaluation. So I'm going to recopy this one on my Word document because I'll need room. So it's 4x squared minus 9. So let's get down to the new page. So we're doing, I don't even remember what number this is, 16. 4x squared minus 9 is my function. And I want to do f of x plus h minus f of x all over h. So what's going on in this is that you're doing two different functions. You're working on f of x plus h, and you're doing negative f of x. So f of x plus h means where there was an x, you're going to replace it with a binomial. So 4 parentheses squared minus 9. Where inside the parentheses, we now put x plus h. So we're going to write that twice because it's squared. We're going to FOIL it. So x times x is x squared. We get an xh. We get another xh. We get an h squared. Bring down our minus 9. We can distribute our 4, or you can add the like terms first, whichever way you want to do it. And if you add those like terms in the middle, you get an 8xh. So this guy right here is going to stand in for this whole entire first part of that numerator. The second thing we need to do is this evaluation. That is saying do the opposite of f of x. So it's just -1 times the function. So that would be -4x squared plus 9. Okay, so once you have both of these worked out all the way till you've done as much as you can, you come over here and you write a big fraction with an h in the bottom because that was in the original formula. On the top, you're going to write the answer for the asterisk. So I'm writing those 4 terms, and then I don't need to do anything with this sign. I've already done it right here. And then I write the answer for the star. If you've done this correctly, you should have some cancellations. 4x squared and -4x squared add to 0. -9 and +9 add to 0. That leaves me with 8xh plus 4h squared all over h. Notice everything has an h, so you can divide an h out of everything, and that gives you no more denominator because you divided the h out. So it's just 8x plus 4h, and that's it. There's nothing else you can do. They're not like terms. So are we okay with that one? I mean, really, it's difficult. I will agree that most people struggle with these, but it's just taking your time and working out the evaluation for each part. Okay, so at this point we're only dealing with function stuff now, and I think we're at the transformations of functions. So let me see what's next on the list. Yeah, because we said don't worry about 17. I know, just try your best to put something on there for the practice, so you can get the points, just at least attempt it, but I would study for 16. So I think some people asked for some of these later questions at the very beginning, and I think 1 or 2 of those people left because they were waiting so long for their questions. So I'll have to make sure I post them still. I want to say Erin asked for 19 and 24. So let me scroll back up and see. I know she's not here, but it doesn't hurt, and I'll still post it for everybody. There's way too many yes, good, no. Does anybody see? If you have one in this group that you see, you can also type that in a second. Yeah, Erin asked for 19 and 24. So I'm going to go ahead and throw those on. Does anybody have anything different in this little group, 18 through 24? And this was the stuff we just covered. So I'm going to mark 19 and 24 real quick. You guys good? I can't see if anybody typed anything new. It didn't pop up. Okay, I have 22 and 20 as well. Okay. So for these, we are graphing these transformations of those parent graphs. So remember that remember the shape of an absolute value is a V. So we know that this graph has that V shape, and that's typically centered at the origin, and it has a point 1, 1 and -1, 1. I'm plotting those in the wrong order that I'm saying them, but it has those 3 points. It's that V shape. This is a +4 outside of the absolute value, so this is going to be a shift up 4. So you just have to move each of those 3 points vertically up 4 points. So here's -1 and +1 and 0, 1, 2, 3, 4. So that point at the origin would move up to +4. These both had a height of +1, so now they're going to have a height of +5. And then we graph it won't let me do that. We graph the V shape. It doesn't like that there's a page break there. So you're just moving that graph up 4 points from its original location. Is that okay for number 19? Because that one is kind of a building block for number 20. Are we okay with that? Okay, so for 20, we have two transformations. There's a -1 inside the absolute value, which means we're now doing a horizontal shift. So this is going to be right 1. You always do opposite of what you see when it's inside. And then this is a vertical shift again, and it's exactly what you see. So it's going to be down 3. So again, you can imagine that V shape over here, the absolute value of x. Got to give myself some more points this time, though. So we take whatever point we had, so I'm going to start with 0, 0, and I need to move it right 1 and then down 3. So 0, 0 goes right 1, down 1, 2, 3. That's its new location. The point -1, 1 was up here, so we need to move it right 1 and then down 1, 2, 3. And the point +1, 1 was on the original absolute value, so we need to move it right 1, down 1, 2, 3. So that is the new home of that absolute value. Any questions on 20, or do we feel okay with that? And again, if you feel terrified of this for some reason on the test, just make an XY chart. Here is the quickest way to get this correct. If you want to make an XY chart, make sure whatever you put in the center of your chart makes the inside equal 0. So start with 1, put a 0 and a 2. If you do that, you will be able to plug that into the equation and get the same 3 points that I got here. Okay? So if you ever freak out, because remember we said you don't have to graph this by transformations. The only rule is have 3 points. So if you take whatever's inside and you just make sure that your center of your chart makes that equal 0 and pick a number smaller and a number larger, you should be able to graph it. Now that's true for these. It is harder with the square roots. For the square roots, you have to only pick numbers bigger than this because you can't go negative. You can't go imaginary. But, you know, for this absolute value, you literally could do it that way and you would get the same 3 points. So the inside always shifts x, the outside shifts y. Anything that happens inside of the parentheses or the symbol is an x direction. Anything that happens on the outside is a y direction. Okay, so let's look at 22. 22 is the x squared. Remember, x squared guy is the parabola. So we're looking at a U shape. So I'm going to make a little mark over here for 22. So original x squared has the shape 0, 0, because 0 squared is 0, 1 squared is 1, -1 squared is 1. It has the same 3 points as the absolute value, except instead of a V, it's a curve. And that's because you're squaring things instead of taking the absolute value. So this is what the parabola looks like. We have 2 different transformations. If you do -x squared minus 1, you have to do the thing closest to x first, which would be multiplying by -1. This is a reflection over the x-axis because it is not inside the function. If it was inside the function, it would be in a parentheses. So it makes your y values go from positive y values to negative y values. That's why you flip over the x-axis. And then this is a -1 that's not inside the function either, so it's afterwards. So this means we shift down 1. When you graph things where there are multiple transformations, the one that happens order of operations first needs to go first in the list. So this needs to happen first because it's closer to the order of operations I would evaluate this in. So the first step would be to just flip the whole graph upside down. So that's the reflecting over the x-axis. It's not my final answer, but that's step 1. And then the second step would be to move all of those points down 1. And that would be my final graph. So I'm at 0, -1, -1, -2, and +1, -2. So I'm just taking each of these 3 after I flipped them. And flipping them, you don't change their values, except that y's go from being positive to negative. So notice those were still a height of 1 away from the origin. So we just moved everything down 1 point. Any questions on 22? Are we okay? Because we're almost to the end of the battle. We've almost made it to the end of the review. So for number 24, you have a parent graph that is the square root of x. So we are looking at this shape. This is the one that's the hardest out of all of them for the table of values, because you can't plug in negatives in here because they would be imaginary. So you have to plug in square root of 0 is 0. I use perfect squares. Square root of 1 would be positive 1. I don't plug in 2 or 3 because they're not perfect squares. I plug in 4. Square root of 4 would be positive 2. So remember, that's our parent graph. That's the original square root of x. When you do negative square root of x minus 2 minus 4, this has 3 different transformations. The inside part you do the opposite of. So instead of moving left, we're going to move right, because remember, that's a horizontal change. This is again a reflection over the x-axis, because it's a negative in front of my function. And then this one is a shift down 4. Okay, so we need to do each of those one at a time until we get to our final graph. So the first step would be to take this whole thing, and again, you have to know your order of operations. We need to subtract 2 before we take a square root, so that means that's the first step. And then we would need to multiply by negative 1 before you could subtract, because multiplication comes before adding or subtracting in order of operations. And then vertical shifts are always the last thing when you have multiple stuff. So the first step is going to be taking this whole graph and moving it right 2. So first step, take each point, move it right 2. So 1, 2. The point 1, 1 is going to go 1, 2. So now it's at 3, 1. The point 4, 2 is going to go right 1, 2. So now it's at 6, 2. So that's step 1. I just moved it right 2. The second step is I'm going to flip it over the x-axis, which means I'm going to take all of those and flip them upside down. So the 2, 0 is still going to be on its same spot because it's on the x-axis. The 3, 1 is going to flip to 3, negative 1. The 6, 2 is going to flip to 6, negative 2. So now notice my graph is upside down. The final step is we're going to shift each point down 4. And that would be what you would put on your final graph for your actual test. You would have to take those the last transformation is what goes on the graph. So I need 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, 7, to give myself plenty of room. So 2, 0 is going to move down 1, 2, 3, 4. 3, negative 1, so let me find that point, is going to move down 1, 2, 3, 4. And then this was 6, negative 2. So 6, and then down 2, and then I'm going to move down 1, 2, 3, 4 more. And again, you'll have nice grids on your test, so your graphs will look a little bit straighter than mine, but notice I just did it one step at a time, and this is the final answer once you've completed that last transformation. So that one's the hardest one because it has that square root of x and it has 3 different transformations. Are we okay on that one? All right, so this brings us to our final 3 questions. 25 and 26 are piecewise, and then 27 is about just 27 is actually the first question on the test. You just have to tell me if this has one of those 3 symmetries or none. Can you fold it over the y-axis, the x-axis, the origin, or none? And then you have to tell me what the x and y intercepts are. Tracy, you can do all the steps or you can just give me the final graph. The only part I'm looking for on those transformations is that last step. That's what I want you to put on the actual graph that's on the paper. If you need to show your individual steps to get there, that's fine. Or if you can just move it and do it as you go, that's fine. It doesn't have to be as written out step by step as I do it. Does that answer your question? Okay, does anybody need to see maybe 25 or 26 or 27? Okay, 25. 26. Are we good with 27? Okay, and 27. We might as well finish strong. All right, so I'm going to need more writing space for these, so I'm going to go back to my, excuse me, to my Word document. And I'll try to remember to post this as well, as long as it doesn't delete itself before I get there. So for 25, we are looking at, and I've already forgotten what the function is, x squared minus 1 when x is less than -2. Yeah, it's going to take me a second. Actually, let me see if I can make my life easier. Minimize. No, that probably is not going to help. All right, so yay, okay. So f of x equals x squared minus 1 when x is less than -2, or 4 minus x when x is greater than or equal to -2. This is that piecewise function, and all you do to graph a piecewise function is you make however many rows you have, that's how many table of values you make. So if you have an xy chart for each one, so x squared minus 1, 4 minus x. The part you have to worry about, though, is the domain. This says you want to keep your x's less than -2. Now, we do also want to include -2, even though it's not equal to here, because it's our endpoint, and it's going to be an open endpoint because there's no equal to. So this is an open endpoint. And then less than -2 would be -3 and -4. So if I plug those into this, -2 squared is 4, minus 1 is 3. -3 squared is 9, minus 1 is 8. -4 squared is 16, minus 1 is 15. Okay, and then I'm going to do this group. So this is for when x is greater than or equal to -2, and that means I'm going to have a closed endpoint this time because of the equal to. And greater than, so I could do -1 and 0. You just need a couple points. So this is where you have to be careful. 4 minus a -2 would actually be 4 plus 2, so that's 6. 4 minus a -1 is 4 plus 1, so that's going to be 5. And 4 minus 0 is 4. So once you have at least 3 points or sometimes more, depending on how comfortable you are, for each of your graphs, making sure I can go all the way up to 15. Okay, so for this one I have -2, 3, so -2, +3, and that's an open endpoint. And then -3, +8. And that's too far over, sorry. And then -4 is at 15, which is way up here. So these aren't lined up perfectly because I'm trying to graph without grid lines. And this has a parabola-like shape because it's x squared, so notice it's kind of curved. And then 4 minus x, we're going to graph it at -2, +6. And that's a closed circle, which is fine because it still passes the vertical line test. -1, 5, and 0, 4. And then this is a straight line because it's got a slope of -1 and a y-intercept of 4. So it doesn't look like it's y equals mx plus b because they wrote it in the wrong order. So that's it. You're just graphing the two individual pieces. Any questions on that one? Ah, that's my email. Not what I wanted. So do we still need to see 27, or did that clarify that for the people who wanted to see, or sorry, 26? So how many table of values would we need? We'd need 3. Because you'd have 3 rows. So you have 3 different table of values. Does anybody still need to see 26? I don't mind doing it. I just didn't know if that clarified it, and I didn't want to kill a dead horse. Okay, so for this one, you have 6, and then x squared and 3x minus 8. So I'm doing that more for my sake than yours. Let's see. I am using up the ink on this tablet tonight. So f of x is 6. I've already forgotten. Literally a fish brain. X squared and 3x minus 8. So those are my function parts. Gosh, I just forgot what it was again. This is why I need a nap. 3x minus 8. All right. And then my domains, I want to say one was like -4 to -2, but I'm going to pull this over so I can just copy it correctly. Yeah, the first one was -4 to -2. Whoa. You'll notice my computer's starting to freak out because there's so much ink on the screen, it doesn't know if it can actually hold it together. It's like -2 to 2 and greater than or equal to 2. Okay, that's everything we needed. So for this first table, we're going to be graphing y equals 6. That's what you would think of this as. And that is between -4 to -2. So -4, -3, -2. And notice both endpoints, since we do have 2 endpoints, are closed. Endpoints are the numbers that either start or end here. So this is closed because of the equal to, and this is closed. There is no y value or no x value to plug in for, so this is always 6. For the second one, y equals x squared, you are doing that one from -2 to 2. So -2, -1, 0, 1, 2. Sometimes I'll do all the points in between. Both of the endpoints here are open for the 2 and the -2 because of the non-equal to's. We're squaring, so -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And then the 3x minus 8, we are doing greater than or equal to 2. So that would be 2, 3, 4, and then it continues forever. So this is also a closed endpoint because of the equal to. And this would be 6 minus 8 is -2. 9 minus 8 would be 1, and 12 minus 8 would be 4. So we would need to plot all the pieces. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so -4, 6 is right here, and it is a closed endpoint. And then we go to all the way to -2, 6. So that's just a little closed endpoint and the segment in between it. Not very interesting. -2 is at 4, and it's open. The points in between are not open. They are just points. It's only the endpoints that can be open or closed. And then the last part is the 3x minus 8. So that one was 2, -2, and that was closed. And then 3, 1, and then 4, 4. And this one continues up forever because this does not have a second endpoint, whereas these are stuck in between. So does that clarify for number 26? All right, which brings us to our last question of the night. 27, and I think I can do it on the original paper. Okay, so this says label all your x and y intercepts and state whether it has symmetries of x-axis, y-axis, origin, or none. X-axis means if you actually folded this piece of paper on the x-axis, would the top be a mirror image of the bottom? And that is not true here. Y-axis, if we folded it on the y-axis, would it fold over and be a mirror image? This one is a yes. So this has y-axis symmetry. Origin means if you fold it twice, over the x-axis and down, and that would not match up exactly. So typically how you can check really quickly for origin, if you have a point -2, 0, you must also have the point 0, -2, and we don't. So whatever a point is, you have to have the flip of it as well to be origin. So this one has the y-axis symmetry. The ordered pairs are -2, 0 for the x-intercept here, 2, 0 for the other x-intercept, and 0, 4. So x-intercept, x-intercept, and y-intercept. And then for B, this one does have origin symmetry because if you look at this, first of all, if you fold it across the y-axis, you would need a match up here. We don't have that. If you fold it across the x-axis, it doesn't match down here. If you fold it twice, it would match. So this one has origin. And this one has no intercepts. These lines, they get closer, but they never cross. So this one has no x or y intercepts. For C, this one folds over the x-axis, so that would be x-axis symmetry. It has intercepts of, it looks like -3, 0 for the x-intercept, and 0, 3, and 0, -3 for the two y-intercepts. Now notice that's not a function, but it's just, it has this symmetry and it has those intercepts. And the final one, this one's a tricky one. This looks like it has the symmetry we just saw, but maybe the y-axis, but it's not centered at the y-axis. If you fold this part over, there's no point down here for it to match. So this one has none of the symmetries. It doesn't fold over any of the axes nicely, but it does have 0, 1 as a y-intercept and 1, 0 as an x-intercept. Okay. So that is all of 27, and I believe that's the last question. Yes. So anything else you guys want to ask me before we shut off the session for the night? I am going to post this, but I'm also going to post a formula sheet real quick of just a summary of all the formulas you need to be familiar with. And I'll post that as announcements. So this video will probably take a little bit of time to process. Because it has to render and then I have to upload it to YouTube. But I will post my PDF of the work that I just did on all this ink, and I will post the formula sheet right away. The video might take another hour. So, any other questions, or are we okay? Ty, how far up? Okay, my number 26 was on the other page. Do you need me to go to that, or do you just need to see the problem? And then I saw your question, Mung, about 18. I'll go up and look at that one next. Yes, I'll go back to 27A in just a second. And anybody who's done, you can sign off at any time. You don't have to stay the whole time. So is it possible? Let's see. So let me go to the page real quick for Ty, And then I'll look back at those other two questions. So for 26, here is the graph. Okay. And then Mung asked about 18 and Ibram asked about 27A. So let me look at 27A real quick. The domain of 27A would be negative infinity to infinity. This graph would continue going down forever, which means you would any x value you find, you would be able to find a y value somewhere. We don't ask you for the domain and range of these, but that would be the domain of it. Does that answer your question on that one? Its range would be negative infinity to positive 4, because the highest it ever gets is positive 4, because there is the vertex right up there. Okay, so let me pull back up to 18 real quick. And okay, this is that description where you have to write the description of the transformation only. So notice there is a negative inside the function. That means we have a reflection over the y-axis or across the y-axis, if you want to think of it that way. You have a 1/2 in front of the function. Remember, we're not graphing this, we're just describing it. So anytime you have a number in front of the function, it's going to be vertical, and it does exactly what you think. So a number bigger than 1 stretches you bigger, a number less than 1 compresses you smaller. So this is going to be a vertical compression by 1/2, and then this is shifting down 6. Now that's all of my little notation. I have to write this as a sentence. So I'm going to say g of x is f of x, and make sure you write these in the order of operations. So this would be first, timesing by 1/2 would be second, and then subtracting 6 would be third. So g of x is f of x reflected across the y-axis. Oh no! What just happened there? Okay. I don't know why my ink is no longer working, but I'll tell you what I was going to finish saying. So it says it is a reflection over the y-axis, compressed vertically by 1/2 and shifted down 6. I was just going to write that as a sentence, but now my pen has decided to revolt. So I have no capability to write at the moment. That's not good. Because, okay, so notice, remember in class we had like the letter y here. We said y is f of x. This is just saying the new function is the old parent function. So this says your new function g of x is a transformation of f of x. Does that explain that, Ty? Okay. All right, guys, so anything else off the top of your heads? Because I'm going to have to go to bed soon. Okay, so Ty, you're good. Tracy, you still there? Are you good? Ibram's good. Okay. I'm not seeing anybody reaching out for help or crying, so I will see you guys depending on which class you have, either tomorrow or Thursday. Get good rest, and the day of your test, try to eat a healthy breakfast. I'll be that. I'll plug that. All right, I'll see you guys in class.